So here we have a new concept for zeros. This video probably follows the first video that defines what zeros are. Okay, so if you're watching this without having seen that, you may want to go back and refresh your memory on what zeros are, what the definition of zeros are. And I say are because there's multiple different definitions and how we define those kind of determines how we solve certain problems. So, for example, we're going to look at what's called the multiplicity of zeros. Okay, when you talk about multiplicity, you're talking about a process that's repetitive, that happens over and over and over again, right? So multiplies. We'll get into that in a second. But this says sketch a fourth degree polynomial. Okay, fourth degree even degree polynomial with a positive leading coefficient. So let's stop right there, pause, and say if this is fourth degree, that's an even degree, okay, with a positive leading coefficient, right away we know that the end behavior of this graph is going to look like this. It has to, because it's an even degree polynomial with a positive leading coefficient. I don't know what's going to happen in here, but I know without a doubt that it's going to rise to the left and it's going to rise to the right. Okay. Now they want us to sketch this, and it has these zeros, right? -7, -2, and 5. Now, what does that mean? The zeros are x-intercepts. Remember, that's an alternative definition for what zeros are, x-intercepts, okay? So we know that this graph crosses the x-axis. I'm going to put -7 over here. We know that it intercepts the x-axis at -2. I'm going to put that right here. And it intercepts the x-axis at +5, which is right here, okay? So when you look at this function, right, and you look at these intercepts, and keeping in mind what its end behavior has to be, we know that this graph, once it gets to here, it has to rise to the left. It's not going to come back down, because if it comes back down, and knowing that the domain is already from -infinity to infinity, there's no breaks. If this graph turns back over, okay, it's going to cross the x-axis again. But these are the only 3 zeros of this graph. So I know that from its leftmost intercept, it has to go up. And I also know, because of its end behavior rising to the right, from its rightmost intercept, it has to go up. And now, like I said from the beginning, anything can happen in here, okay? So what could how does a graph also hit the x-axis here and here and here? If it crosses over, right, what has to happen? It's got to come back up, right? Well, if it comes back up and it crosses over, it's got to come back down. But I can't cross the x-axis again, right? Now, and again, this could go lower, this could be shallow. That's not what we're really focusing on. We're focusing on what could happen here, okay? This graph could come back down, and if it's only going to cross the x-axis one more time, right, it would have to do this, right? It would touch this x-axis, and then what we refer to as it would bounce off the x-axis, okay? And when a graph bounces at an intercept, now it's still an intercept, right? Notice we didn't say it doesn't have to, quote unquote, cross the x-axis. It just has to intercept it. So what that means is it has to touch it. It can cross or it can bounce, okay? Now when it crosses, okay, we say that this zero has an all odd multiplicity, okay? That means it could be a zero, that could be a zero once, it could be a zero 3 times, okay? It could be a zero 5 times, ... okay? When it bounces, we say that this zero has even multiplicity, okay? And we'll talk about what this looks like in the function itself in a different video. Just understand that a bounce off the x-axis means the zero happens an even number of times. That means it could count as a zero twice, or it could count as a zero 4 times, so on and so forth. Now, the way that I drew this isn't necessarily how this has to go. This isn't the only correct answer, right? What else could have happened? Because they didn't specifically state what the multiplicity of all of these zeros was, okay? We know what it's going to do at the leftmost zero and at the rightmost zero, but maybe it bounces here, crosses over, comes down, and then comes back up. This is an alternative possibility. In this case, this would be the bounce. This would be the even multiplicity, right? This zero would count more than once. This zero could count one time or three times, right? It really only counts once, and we'll talk about that later on in a video. Just understand that a zero counts twice if we bounce, right? It could also count four times or six times or eight times, right? That's an even multiplicity if we bounce. If we cross over, that's an odd, what we call an odd multiplicity. Okay.